Okay, this is, I think, maybe the last one we're going to do is this kind of conclusion. Yeah, it should be 9. Anyways, and it's just like a wrap up on this and like my general thoughts about this project. And also, you know, you can. I think I'm going to make this available as a kit if anybody wants it. But I just want to mention a few other things that weren't really talked about specifically, and let me say the following. Now, there's a lot of talk about capacitors and like which ones are best and so forth. You got electrolytic, film. I'm obvious. I don't know if it's obvious, but I'm not an expert on this. I can tell you what I have done. I mean, and I'd like to hear comments on that because this is one with people who have a lot of different opinions on it. But I can tell you what I've done with this preamp in terms of its capacitors. And it's kind of funny, but what I did was I built this thing, and I used all 100% multi-layer ceramic capacitors. Whoops. Now, I know that's the wrong thing to do. That's why I built it that way, because I wanted to sort of really check it out with those. And what I did was I built it with multi-layer ceramic capacitors. I hooked it up to a power amplifier, and I had the amplifier totally, completely all the way up. And see, I had the gain all the way up on everything on the amp, so that like if you breathed on it, practically you could hear it. And I had my guitar plugged into it, and I had my volume on 0. So if you can imagine, like whatever, this massive gain, everything's 100% up all the way, and your volume's at 0 on your guitar. Everything is so sensitive at that point. And I did this, by the way, with other amplifiers, not just my own. Just out of curiosity, I really like to sort of see how quiet things can be when they're maxed out for comparison. And mine was actually quieter than everything I tested, but not with the multi-layers in it. But then I went around on the circuit, and I either physically vibrated them, tapped on them, tried to get them to make noise any way I could, and I went through each and every capacitor on here, and I marked kind of a level, like noisy, quiet, whatever. And after that, I sort of I just kept a table of that, which ones really need high quality capacitors in them, which ones you can get by with maybe a multi-layer here or there. And I don't actually have a table of this on here, but the bottom line about that is if this is a rule that it seems obvious, but it's also true through my experimenting, and it's that any capacitor on the base of a transistor, like this one, this one, they all 100% have to be filmed. I mean, you can't use multi-layer or anything. Now, if they're sort of paralleled off the side, like here, you can actually get by with multi-layer. I mean, in my opinion. Now, there are different distortion properties and high-frequency distortion, microphonic properties, and all this. But I'm just telling you, like from a standpoint of how much money and how much effort do you have to put into putting in these capacitors, that you can't really tell too much that they're that important. I mean, for example, in this compressor circuit on this is a low gain compressor circuit, you don't have to use films there. I mean, you might be concerned about that they're matched properly, but so I just want to sort of mention about that. And and one of the reasons I try and use the multi-layers, and again, this is not what a lot of people do, but I do because they're so sturdy. I mean, they're compared to like electrolytic capacitors. Like if you have a equipment and it dies for some reason, I mean, it's almost always an electrolytic capacitor, or very frequently. I mean, you could make a living off of simply replacing electrolytic capacitors in broken devices because they just have a time limit on them. They dry out. They just stop working after a while. So if I can get away from not using them, I do, and that's why you'll see in these circuits I don't have a whole lot of capacitors above 10 microfarads, and when I do, I try and actually plan for failure. And I can show you that like right here, for example. On my board, this is a schematic, but on my board actually, I have, I think, 10 I think I have like 10 microfarad multi-layer capacitors here in parallel with this 470 microfarad. If this thing totally goes out, it still works. It's noisier, but it doesn't oscillate. It still works. It's totally usable. Here I could stand a filter out a little bit more there, and haven't because I'm using it now. I've these ones here, like these capacitors for sort of filtering out high gain oscillations and so forth. I did these experimentally. I mean, I just started low and went high until I found the right stuff. And by the way, this will, with bad power supplies, this will not work without these capacitors. It will oscillate for sure. I originally built this without this filtering in, and I used one of those one-spot power supplies, and I didn't really need anything until I tried to really, ordinary or bad, poorly filtered things, and it was totally necessary. I'm trying to think if there's other things. I'll just mention this since it's on here, but at one point I had a speaker simulator basically, and I just rolled off a ton of high-end frequency and made it as sharp as I could without adding too many parts, and made it actually pretty usable. It was better than I studied probably 4 or 5 speaker simulation circuits, and I'm gonna, that'd be a whole other topic, but I had on here that you could throw these 2 capacitors in. Now remember I said in a different video, like you have this here, right, and you can use a roll-off. You can roll off a little bit of frequency there. Then I've got this one here, and you can roll off more frequency there. Then I have this one here, which rolls off a little bit, and then I have this one here that does. Now this one and this one are always on, and they help out, but they're barely audible. And then these 2 thrown in, the 4 of those together roll it off well enough to where you can take that signal out and run it into whatever, like a direct line into a recording device or computer. And it's not perfect by any means, but it makes a signal that's usable. Meaning it's going to need EQ'd a little bit more. Like if you were going into a board or something, you're going to have to correct it more with whatever controls you have there. But it's way better than, like I looked up a Marshall circuit, a Carvin circuit. I went through. I've read a lot of these speaker simulations, and like this one was better than most for sure. Definitely better than the Marshall quote, voiced output or whatever it's called that you may see. But those aren't intended to really make a line out that you can use well. I mean, it takes a signal that's so hideous and makes it usable. And that's something else I can kind of mention about this is, like, this preamp is made to go into a power amp with no EQ. Just goes straight into a power amp, and that power amp goes into a 12-inch speaker, or some type of cabinet that's kind of similar to a 12-inch speaker. That's what it's made for, because it's the intention is, well, this is a sturdy preamp that will work for you for a long time. Pick up any type of amp and then just go from that to a speaker. It's not intended to go into a full range speaker like a studio monitor, or a studio monitor. This would sound horrible through, because it's a full range speaker. And when you go into a 12-inch speaker, you're getting all this treble roll off and some bass roll off too, actually, and that continues to shape the sound. So if you ever would try and run this direct, I mean, it's not going to sound good, but if you wanted to do that, you should put this on there for sure. And that'll make it into a signal that can be modified somewhat after that. But I really wouldn't recommend this. This is more of like a live amp. Now, I could, if people really wanted that, they're like, we really need direct out recording on this. It's not hard to do. I mean, I could come off of like I could probably come off the effects loop and just go through a little more circuitry, shape it, and get it to where it matches a cabinet and everything. It's not really that hard to do. But it's not gonna, the speaker and in the room and the cabinet, everything colors the sound more. I mean, I can get the frequency spectrum right kind of easily, but So, see if I got anything else to say about this. Well, if anybody, I did kind of make this. If I didn't really go over the power supply, but it's not worth talking about. If anybody does want this preamp, I mean, I'm making. I've got some extra boards. I may even sell them if people like them. So, but I do, the way I'm having it made right now is that I'm ordering it with, it's a combination of surface mount and through hole stuff. And like the surface mount, let me pause this and bring it up. So it's kind of a combination of surface mount stuff. Now, there's a easy EDA. It is from China. I mean, it's a nice program. Here's different look at my amplifier. Let me kind of pull this out here. This is again, it's just random notes of my own, but you can kind of see it's wonderful actually, and I'm sure there are many other good programs, but you can go through here. Let's see here. Well, here it is. Here's this capacitor stack I was talking about on this. This is a distortion area. Again, they got different notes and so forth. I'll kind of show you the PCB. I did vertical mount on all this stuff, and I'm using some of these. Let's see if I can bring this in a little bit differently. Okay, so sorry, I'm trying to get this to record okay on the screen. Well, that's obviously far away, but I'm using some vertical pots, and I've got a combination of like all the important, like there's the electrolytic capacitor, film, another film, different stuff. But I've also got, I've also used some surface mount multi-layer capacitors. I've got pots, switches. Here's a 1/4-inch jack. Let's see here. I use these two. These are kind of PJ301BM. I'll show you that. PJ301BM. These are really nice. These are kind of, smaller jacks that they use on like synthesizers and stuff, but I put them on my effects loop and output, and I just kind of use a little adapter because they're so they're so easy to vertically mount on. It just makes it so simple. But of course with the input jack, I've got like a right angle adapter and everything. But those are kind of nice. So this gives you an idea. It's not super. I mean, it's relatively simple, I think, for what it does. So there's the whole thing. Here's a faceplate for it. So you can see there's, you get compressor, so forth. I call it 2B. I mean, it's silly, but it sounds like a tube, so it's tubey, And the tube simulator, maybe that's overreaching, but it sounds tubish to me. So I even got a little bit of a back plate here. I can't really see it, but let's see if I can render it differently. There we go. It's kind of I'm not the best with this, but yeah, you can see there's the back and stuff. Smaller jacks for this stuff. So if people like it or want it as a kid, I mean, I'm not gonna I'm not gonna charge an arm and leg for it. I mean, it's not like something I anticipate getting rich off of or anything. But I mean, if people like kits, I know there's not that many rack mount guitar preamp kits out there. I don't know of any. So if you want one, I guess it would. I'm gonna put one out there. So maybe in the comments or something, I will have like a link where you can buy it if you want. But otherwise, I'm just happy to share the knowledge with you that I gained from making the amp, or preamp rather. And if anybody is interested in any way about stuff like this, just keep in touch. And otherwise, thanks for watching. So stay safe.